Have you ever wondered how the world of mathematics has evolved alongside the advent of artificial intelligence? Let's take a step back in time, to an era where mathematicians used to rely heavily on pen, paper, and their intellect to seek out what they referred to as pure and elegant solutions. It was a time when problem-solving was a test of mental acuity, perseverance, and raw human ingenuity. Then came the 1970s, a decade marked by a technological revolution that brought computers to the forefront of problem-solving. Mathematicians, although initially hesitant, began to see the potential of these machines to assist them in cracking the hardest math puzzles. The advent of computers in mathematics was a significant shift, allowing for faster calculations and the ability to tackle more complex problems. Fast forward a few decades, and computers have become an integral part of the mathematical problem-solving process. They're no longer just tools, but partners in the pursuit of knowledge, helping to crack even the most complex mathematical conundrums. As the digital age progressed, mathematicians started to explore new avenues, one of which was machine learning. This exploration marked a new era in problem-solving, bridging the gap between the traditional approach and the future of mathematics. It's a fascinating journey, and we're just getting started. As the digital age advanced, mathematicians began to embrace a new ally: machine learning. This budding field, a sub-branch of artificial intelligence, has been making waves across multiple sectors, and now it has found a home in the realm of mathematics. Machine learning is a fascinating concept. It's akin to training a computer program to think and learn, much like a human brain. These programs are fed vast amounts of data, from which they learn to recognize patterns, make predictions, and solve complex problems. It's like giving a computer its own pair of spectacles, enabling it to see and understand the world in a whole new light. Sergei Gukov, a leading figure in the field, has been instrumental in promoting this intersection of mathematics and machine learning. He envisions a future where these two disciplines collaborate and complement each other, bridging the gap between the creators of machine learning tools, the data scientists, and the mathematical community. But what does this mean for mathematics? Well, it's about taking a centuries-old discipline and injecting it with a dose of digital innovation. It's about adding another tool to the mathematician's toolbox, one that can help tackle some of the toughest problems in the field. It's about exploring new approaches, finding novel solutions, and pushing the boundaries of what's possible in mathematics. This marked the beginning of a new era in mathematical problem-solving. The collaboration of mathematics and machine learning is not just a one-way street, it's a two-way thoroughfare, bustling with the exchange of ideas, innovations, and problem-solving techniques. This vibrant intersection of fields is where Sergei Gukov, director of the Riemann Center for Pure and Applied Mathematics, finds himself. Machine learning, a subset of artificial intelligence, thrives on crunching large data sets, identifying patterns, and making predictions. It's a powerful tool, but without a firm mathematical foundation, it's like a ship without a compass. Mathematics provides the theoretical underpinning that guides machine learning, ensuring it navigates the vast ocean of data accurately and efficiently. On the other hand, the application of machine learning in mathematics is like a fresh pair of eyes, bringing a new perspective to age-old problems. Machine learning algorithms can sift through complex data, offering mathematicians novel insights and solutions that may not have been immediately apparent. Gukov's role at the Riemann Center is akin to that of a bridge engineer. His work connects the developers of machine learning tools, the data scientists, with mathematicians. The aim is to create a dialogue, a collaboration, where both fields can learn from each other and grow together. This symbiotic relationship between the two fields has opened up new possibilities in problem solving. It's like a mathematical dance, where each partner brings their unique moves to the floor, complementing and enhancing the other. The result is a performance that is greater than the sum of its parts. A new era in problem solving, where the lines between mathematics and machine learning are blurred and the possibilities are endless. One of the toughest puzzles that mathematicians are hoping to unravel with machine learning is the Riemann hypothesis. This enigma has been lingering in the realm of mathematics since the 19th century, when it was first proposed by Bernhard Riemann. The hypothesis is one of the 7 millennium problems selected by the Clay Mathematics Institute, and it comes with a hefty prize. Yes, you heard it right, a $1 million prize awaits anyone who can solve this intricate mathematical problem. Now you might be wondering, what is this Riemann hypothesis? Well, in non-technical terms, it's a conjecture about the distribution of prime numbers. Prime numbers, as you might remember from your school days, are those numbers that are divisible only by 1 and themselves. The Riemann hypothesis suggests a certain pattern in the way these numbers are distributed along the number line. However, despite its seeming simplicity, the hypothesis has proven to be incredibly tricky to prove or disprove, even for the most brilliant minds in mathematics. This is where machine learning could come into play. Machine learning, a subfield of artificial intelligence, is excellent at recognizing patterns in large data sets. And what is the Riemann hypothesis if not a question about patterns in the distribution of prime numbers? So, there's a hope that machine learning could help in cracking this hard nut. By training an AI on vast amounts of data about prime numbers, mathematicians are hoping that it might discover the proof that has eluded human minds for more than a century. Of course, this is all highly speculative at the moment. There's no guarantee that even the most advanced AI can solve the Riemann hypothesis. But the very possibility is exciting. It represents a new era in problem solving, where human intellect and artificial intelligence work together to tackle some of the toughest challenges. The use of machine learning in solving such complex problems is a testament to its transformative potential. From abstract hypotheses to tangible knots, machine learning is proving to be a useful tool in various mathematical problems. One such problem lies in the field of knot theory, a fascinating area of mathematics that deals with the study of abstract knots. These knots, unlike the ones you tie on your shoestring, are closed into loops, creating a myriad of entanglements. This is where machine learning steps in, helping mathematicians to untangle these complex abstract knots. Take Sergei Gukov, for instance. Gukov, who we've mentioned earlier, has used machine learning to solve problems in knot theory. He and his team have found that machine learning tools can recognize patterns and analyze these complex knots in ways that traditional mathematical methods may not be able to. But the implications of this work don't stop at knot theory. Gukov's work has relationships with other fields of mathematics, such as representation theory and quantum algebra. And yes, you guessed right, even quantum physics. Machine learning, it seems, has the potential to bridge gaps between various fields, enabling the cross-pollination of ideas and techniques. And what's more, Gukov and his team have written a preprint paper on this subject, aptly titled Searching for Ribbons with Machine Learning. In this paper, they discuss their use of machine learning to solve problems in knot theory, demonstrating the versatility and potential of machine learning in the world of mathematics. Now, isn't that fascinating? How machine learning, a subfield of artificial intelligence, can lend a hand in solving problems that have puzzled mathematicians for centuries? It just goes to show the limitless potentials of machine learning, not just in mathematics, but in various other fields as well. Machine learning has the potential to untangle even the most complex mathematical knots. So, who knows? Perhaps the solution to some of the world's most difficult mathematical problems lies not just in numbers and equations, but also in the clever application of machine learning. Opening. While machine learning aids in solving mathematical problems, mathematics reciprocates by contributing to the development of machine learning algorithms. From the perspective of a mathematician, the development of machine learning algorithms is an engaging puzzle. It's a confluence of pattern recognition, statistical analysis, and computational logic. It's an arena where numbers, symbols, and abstract concepts come together to form a practical working model. Just as a gardener prunes a plant to encourage growth, mathematicians fine-tune machine learning models. They meticulously adjust parameters, optimize functions, and validate results. This iterative process is like a dialogue between the mathematician and the machine. It's a back and forth that gradually shapes the machine learning model into a more effective tool. On the other hand, machine learning can also benefit from the rigors of mathematical thinking. The precision, logic, and structure inherent in mathematical reasoning can guide the design of more efficient and effective algorithms. This might involve developing new mathematical models that can better handle the complexities of large data sets or devising innovative ways to evaluate and improve the performance of machine learning systems. Moreover, mathematics provides a robust theoretical foundation for machine learning. It offers a well-defined framework to understand and explain how machine learning algorithms work. This doesn't just make the algorithms more reliable, it also makes them more interpretable, which is vital for transparency and trust in AI systems. There's also an important role for mathematics in the ethical and responsible use of machine learning. Mathematical models can help us understand and mitigate the risks of algorithmic bias, privacy breaches, and other potential harms. This is crucial for ensuring that AI technologies are used in a way that respects our values and rights. Closing. The interplay between mathematics and machine learning is a potent combination that holds immense potential. With the power of mathematics, we can continue to refine and advance machine learning, opening up new possibilities for scientific discovery, technological innovation, and societal progress. With the advent of AI tools such as OpenAI's Q-Star, the future of math and AI looks promising. This innovative tool, developed by OpenAI, is changing the game in mathematical problem solving. Unlike traditional methods that rely heavily on human input and manual calculations, Q-Star employs algorithms and machine learning to solve complex mathematical conundrums. Imagine a future where AI tools like Q-Star are the norm in education, research, and even in our daily lives. We could see advancements in areas that have been historically challenging, such as quantum physics and advanced calculus. The potential applications of Q-Star and similar AI tools extend beyond the realm of mathematics. These tools could be utilized in various fields that rely on complex problem solving, including physics, computer science, and even in social sciences, where the analysis of large data sets is becoming increasingly important. However, as we embrace this new era of problem solving, it's also crucial to remember the importance of human intuition and ingenuity. AI tools are not replacements for human thinkers, but rather, they are instruments that can help us reach new heights of understanding and discovery. With the development of tools like Q-Star, we're not just finding new ways to solve problems, we're redefining what it means to problem solve. As we look forward to the future, the intersection of math and AI promises to revolutionize the way we approach and solve problems. So where does this leave us in the grand scheme of things? We've embarked on a journey exploring the evolving relationship between mathematics and artificial intelligence, witnessing how these two fields intertwine to create a new paradigm in problem solving. Machine learning, a subset of AI, has been embraced by mathematicians like Sergei Gukov, aiding in the unraveling of complex mathematical problems, such as the Riemann hypothesis and knot theory. On the other hand, mathematics has proven to be instrumental in the development of machine learning algorithms. It's a symbiotic relationship, with each field propelling the other towards new frontiers of discovery. We've seen the collaborative efforts of data scientists and mathematicians at the Merkin Center, and the development of Q-Star by OpenAI as a mathematical problem solver. The potential of AI in mathematics is transformative, and its applications are only beginning to be realized. We're standing at the precipice of a new era, one that marries the elegance of mathematical theory with the power of artificial intelligence. As we continue to explore the intersection of math and AI, we are on the cusp of a new era in problem solving, one that promises to alter our understanding of the mathematical universe.